Good day, everyone. We are now on our exciting part in our discussion in statistics. We are now on hypothesis testing. So, everything that you have learned on our previous discussion is very essential so you could be able to you can be successful in testing hypotheses. This includes your knowledge about the null and alternative hypotheses, the building of this hypothesis, and then the significant the alpha or the um, significant level, and then the rejection region, setting the rejection region, choosing the appropriate test statistics. So everything that we have discussed before will be consolidated in this discussion. So we can apply um, the processes of hypothesis testing in a real life problem. At the end of the lesson, you should be able to compute for the test statistic value. Draw conclusion about the population based on the test statistic value and the rejection region. And lastly, to solve problems involving test of hypotheses. The following are the procedures for testing hypotheses. First, you should be able to state the hypothesis. So always remember that when you are stating the null hypothesis, made use of equality symbol because it relates to a fact. No? The nicotine content is 15%. The average lifespan of the people is 70 years old. So you state it. When you are now choosing the alternative hypothesis which negate the null hypothesis, it made use of inequality symbol. So here you are making your claim. No, it says you can say here that the nicotine content of that cigarette exceeds the normal 7.0. The lifespan of people nowadays is less than the average lifespan years ago. So here you are making your claims. You are deviating from the fact. So you have to state it properly. You can choose between the three inequality based on the context of the problem or what you're trying to prove. Letter B is to set the significance level because this will be very important in identifying the rejection region. I hope you still remember. Letter C is to select the appropriate test and establish the rejection or critical region. So you have to select whether z-test or t-test. That's what we are going to focus on this part. No. Fourth, you should compute for test statistic. I'll give you a table and the formula later on. And lastly, to make a decision. So it's either you'll accept the HO or you will reject the HO or fail to reject the HO depending on the computed test statistic on step number 4. And after having the decision, you should make an implication of this one based on the decision. No, it's either how will this affect the research? What will be its implication based on the context of the problem? Kasi that's the reason naman why we do research. No, the statistic will compute so that there will be a meaningful conclusion and implication for researches. So here is a table that you can use in determining whether z-test or t-test you're gonna use. So for the conditions, this variance pertains to the population variance. So if the population variance is known, it only means that you have the population data and you were able to compute, or the problem has given you the population variance, so you will use the z-test. No, that's why it's seldom used in researches kasi you are required to obtain the population value from a value from the population, a measurement from the population, which is the variance. Kaya most of the time, dahil we cannot handle the population, ang mangyayari, yung variance natin ay magiging unknown. That's why the T statistic is well known in researches. Wala akong nakikita pa so far na gumagamit ng z-test. Unless you are working in a government wherein you have all the data. Like for example, yung PSA, they have all the data when it comes to birth certificate, so they can consolidate and present the total data from the whole population in the Philippines. Yung katulad ng election, yan, pwede natin gawin yung yung makukuha natin dong average and proportion or percentage ng mga voters na bumoto kay BBM, that's based from the population. So, population ano siya, measures. Pero, in researches, dahil limited tayo at hindi natin magagamit ang buong population, magiging unknown siya. Kaya nagiging T is statistics. So, that's the formula. Okay? Yan. So, if you observe here from the rejection region, no, if your HA, if it's two-tailed, no, you have to divide your alpha into 2. Huwag niyo yung kakalimutan. No? You have to divide your alpha into 2. Kasi it's two-tailed, so you have to put an equal alpha on left and right tail of the distribution. Okay, let's have our first example. A random sample of 100 recorded deaths in US during the past year showed an average lifespan of 71.8 years. So since it came from 100 recorded deaths, so that's our n equals 100. So it only means that 71.8 years obtained from this 100 deaths is our sample mean. No? Importante that we know how to get to obtain the given, to determine the given. Assuming a population standard deviation of 8.9 years. O ayan, meron na. Population standard deviation. No? Does this mean to indicate that the mean lifespan today is greater than 70 years? So meron tayo ditong sinasabi, does this mean it's greater than 70 years? Use 0.05 level of significance. So let's state our hypothesis. That's the first one. So una, this is our fact, the 70 years. So you have to state it in your HO that the average lifespan is 70 years. Now, you're trying to see if the mean lifespan today is greater than 70 years. So galing yan dito, greater than. Yan. Kaya naging greater than yung gagamitin natin. Why do you think the researcher came up with that? That's because nakita niya dun sa record niya na 71.8. Tumaas ang mean lifespan. So that this mean that this difference is significance. Significance kaya yung 1.8 difference na yun, that will be answerable by statistic. No, di tayo pwedeng mag-base lang sa figure. So next step is to set the significance level, that is 0.05. No, given na siya. Letter C. So select the appropriate test and establish the rejection region. So since meron tayong population standard deviation, we can get it square so we can have the population variance. So we have to use the z-test, no, kasi known ang population variance. And then our alpha will be, since ito ay one-tailed test, no, ito ay one-tailed, probably dahil greater than, that's right-tailed. No. So we have our z value ng critical value at 0.05 level of significance. So gagawa tayo dyan ng normal distribution. And so here is our right-tailed test. So pag nandito siya napunta, so ang alpha natin ay 0.05. So what will be that value? Tingnan natin dito. So dun sa ating t-table na meron tayo ngayon, so we can have the z value at the bottom. No? We can have this one, yung nasa baba. So 0.05 level of significance is 95% confidence interval. Yan. So 1.96. Yeah, so that's z equal to 0.05. Tignan ulit nga natin sa taas. Z equal to 0.05. Doon pala tayo sa taas titingin. Ayan. So 1.645 ang ating gagamitin. 0.05, 1.645. Yan, kaya 1.645 yan. Positive kasi right-tailed. Now, the rejection region will be greater than 1.645. So you can have this illustration or you can have this rejection region, either of the two. Mas malino kasi pagka yung illustration. Now let's compute z statistic. So the formula, is already given. So our sample mean will be 71.8 based on the problem, minus 70, our population mean, divided by 8.9, our standard deviation, divided by square root of 100, which is Rn. So the computed value is 2.02. So if you observe, the 2.02 lies on the rejection region. No, 1.645, so nandun yung 2, susunod siya kasi 0 tong gitna eh. So, we can now have our decision to reject HO. So, if you're going to reject the HO, eto, you are in favor of the HA. That's what it meant. No. So, ibig sabihin, we have, this implies that the mean lifespan today is greater than 70. No, greater than 70 na yung mean lifespan today. So, that's how we are producing information. So, inaalam natin kung nagbago na ba yung lifespan. So, you have to get sample and test the null hypothesis. Na? So, we have now this implication. So, masasabi na natin ngayon na tumaas ang ating lifespan. Pero, example lang to, no? Kung gusto nating malaman, we can try to record some, we can try to get records from the hospitals, no? Para malaman natin talaga. Second example. Suppose that an engineer is interested in testing the bias in a pH meter. So, gusto nyo malaman kung may bias yung pH meter. The pH meter is trying to measure the pH balance in certain substances. So, usually, the neutral substance has a pH level of 7.0. So, gusto nating malaman kung ito bang pH meter natin is hindi siya bias. Ibig sabihin, hindi siya bumababa or hindi siya tumataas dun sa specific value. So from there, makikita mo na yung null and alternative hypothesis. So we have here a sample of measurements taken. We have here 10 measurements taken on a specific pH meter. So ibig sabihin, 10 beses niyang itinry yung pH meter on the same substance. No? 10 beses, siguro it will just take an interval of a minute para makita kung magbabago-bago. So, obviously, from 7.07, after 1 minute, tinry ulit niya, naging 7, after 1 minute, after some hour. So, nagbabago-bago. So, that this mean there is a bias in a pH meter. Kasi usually, kahit yung mga thermometer, no, nag-iiba-iba yung value niyan. Pag inulit-ulit mo, ang tanong, bias ba talaga siya? So, gagamitin natin yung neutral substance na may automatic na 7.0 pH level. So, let's have our HO. So, the mean pH level is actually 7.0. To test the bias, is the mean different from 7.0? So, sabi nga natin, to test bias, pag sinabing bias, kulang ba, sobra ba? That's what we mean by bias. So, it's either lower, greater than, or less than. So, that's why it's not equal to 7.0. So, since there's no alpha given, that we will use 0.05 level of significance. So, if you observe, our n is 10. No, 10 ang n natin, and we don't have a value for population variance or standard deviation and standard deviation, so wala siya. So we will use the t statistic. Okay? So if you observe on our HA, it's two-tailed test. So draw natin dito sa part na to. It's a two-tailed test. Kasi not equal to. So we have the alpha of 0.05. So, di-divide natin yung sa 2 para mag-share yung dalawa nating tailed, no? 0.025. So, yun yung titignan natin sa ating t-distribution. Our n is 10, therefore, our df is equal to 9. That is obtained from 10 minus 1. So, tignan natin siya. 10 minus 1, 0.0. 10 minus 1, alam ko mali yung sagot dito eh, nung nagturo ako ng online. 0.025, and then 9. Yan. Ano yung ano niyan? Saan sila nag-meet? 2.262. Yan. So, yun yung gagamitin natin. Ngayon. So, dapat ito ay 2.262. Yan. So, let's now create a rejection region. So, if our value will be less than negative 2.685 dito, 2.262 rather. Na ito ay negative 2.262. Ito, mali kasi ito eh. Yan. Tsaka kung greater than 2.62, we will reject HO. So, we will compute now. So, itong 10 natin, kukumputin natin ang mean yan. Mean at saka yung ating standard deviation. Kailangan natin yung computein. So, upon computation, ang ating sample mean ay magiging 7.025. Kunin nyo lang yung mean yan. Minus the population mean 7 divided by the standard deviation 0.044 divided by square root of 10, which is the hour in. So, we'll obtain 1.795. So, yung positive 1.795, kung itong 0, hindi dito siya. Yan. Ibig sabihin, wala siya dun sa rejection region. No? So, what we're going to do is we will not reject HO. No? We will fail to reject HO. Ibig sabihin, if we fail to reject HO, we will reject HA. So, what is this implication? Ibig sabihin, hindi siya bias. Kasi ito, this is state bias eh. No? So, this implies that the pH meter is unbiased or hindi siya biased. Okay? So, that's what we do with testing hypothesis. Now, so we have these steps. So I hope you get to understand. So I have here two activities for you to be submitted in your Google Classroom. So we have our first activity, screenshot and follow the steps, and then the second one. So I hope you get to understand our discussion for today. Yan. So, see you again on our next meaningful discussion. Yan. So, see you on our messenger. Goodbye!